So sine of 270, you really can't draw a triangle. But you can still find the sine of 270. You need to know what 270 looks like in standard position. It points down. There's a different color here. So that's your terminal side. Then you need to find a point on that terminal side. I think the easiest one to work with is 0, -1, but any point will do. Since you want to find sine, and since sine has r in it, you need to find r. But with this simple selection, r is going to be equal to 1. R is the distance from the origin to the point. You can find it with Pythagorean theorem. But as you'll see, you'll just get 1. Then you need to know what sine is in terms of x, y, and r. It's y divided by r. Your y comes from the y coordinate, in this case -1, and the r is +1. I just recommend that you use these points that I use. I think they're the simplest. And when you use the points that I have suggested, then r will always be 1. So y is -1, r is +1, therefore the sine of 270 is -1. Okay. Any questions on that process? Yes?
Do you recommend this memorizing for each sine, y over r, cosine?
I do. Yes. I recommend memorizing the trig definitions in terms of x, y, and r. I think that will make you more fluent. Okay, Alec, can you guide me through how to find the cosine of 90 degrees?
Alright, so the terminal side is going to be based on the x-axis.
Did you say x? I'm going to say y. Okay. So 90 degrees is here.
So it's going to be 0, 1.
Good. The point of interest is 0, 1.
And cosine is x over r.
Cosine is x over r.
Which is going to make it 0 over 1.
Good. The x-coordinate is 0. R, with the point selection that I have suggested, is always 1, but it wouldn't matter anyway. 0 over any number other than 0 is 0. Good. Any questions on finding cosine of 90? Yes?
No, I have one for the first one.
Okay.
Is it 1 or -1?
It is -1.
Okay, I only saw the 1, so I was...
Oh, that's the r. Another thing, r is always positive. Okay. Good. Scott, tan of 0. How does one find that?
Plot stable position.
Mm-hmm.
It stays on the positive x-axis.
Good. Good.
And the point 0.
Good. 1, 0 works. Yep, because it's y over x. Mm-hmm. Good. Oops, sorry. This should be 0. Good. The tangent of 0 degrees is 0. And Julie, how can I find cotangent of 90 degrees with this method?
X over y.
So yes, cotangent by definition is x over y. Good. So you need the x and the y. How can you find that?
X is 1, y is 0.
So 90 degrees is here, right? You need to find the coordinates of a point on that terminal side, on that ray. So I would suggest 0, 1. Okay? Then you just do the x-coordinate divided by the y-coordinate. Because cotan is x over y. So 0 over 1, which is just 0. Okay. Any questions there? Nice. Alexandra, guide me through finding secant of 180 degrees, please. Yep, it's a straight angle. Secant is r over x, very good. The point can absolutely be negative 1, 0, yes. Excellent. Okay, we good? And max cosecant 360. Guide me through that one, please.
The terminal side is just on the x-axis.
Which direction? Yep. Terminal side, which is what matters here, is pointing to the right. Okay. Good, continue.
And it's r over y.
Good. By definition, cosecant is hypotenuse over opposite, but it might help you to know it as r over y. Good, keep going.
So that's 1 over 0.
Yep, r is going to be 1 always with the points that I suggested. And the y-coordinate on the x-axis is 0. So it's 1 over 0, and max that is undefined, cannot sit on 0. Or as Jackie said, if it's under, then it's undefined. Okay. Any questions on finding trig function values for what are called the quadrantal angles? Yes, cotan 90. Cotan is x over y. At 90 degrees, the x-coordinate is 0. That's all that really matters. Who cares what the y is? Because 0 divided by anything is going to be 0. Okay. Any other questions? Okay. It says, suppose that theta is in standard position. We know what that means. Vertex at the origin and initial side on the positive x-axis. Great. Done. We're also told that the given point is on the terminal side of theta. Okay? So 3, 4 is on the terminal side. No problem. I plot 3, 4. Easy. Check. That's on the terminal side. So there's a ray that goes through that point. And since it's in standard position, then the angle goes from the initial side on the positive x-axis to the terminal side wherever it is. So that's theta. We want to find sine. No problem. I know that sine is opposite over hypotenuse. In other words, y over r. I have my y-coordinate. It's 4. I have half the answer. Now I just need r. R is the hypotenuse. It's the radius. It's also the distance from the origin to the point. Okay, that's r. This is y. This is x. So we are still working with right triangles. You can use Pythagorean theorem because it's a right triangle to find r. But this is a very simple one. Hopefully you can see that this is a 3, 4, 5 right triangle. But just to prove that to you, Pythagorean theorem, hypotenuse squared equals side squared plus side squared. And you can write this as r equals the square root of x squared plus y squared. And for your information, this is always how you can find r. with this formula. It's just a Pythagorean theorem re-expressed. Okay, so your x is your x-coordinate. It's 3. Your y is your y-coordinate. It's 4. I recommend subbing in with parentheses. Remember, r is always positive, so if you get a negative or a negative underneath the square root, something's not right. Okay, so this is the square root of 9 and 16. And 9 and 16 is 25. So that's just the proof that the hypotenuse is going to be 5. Then you just divide by that, and it's that easy. So the sine of this angle is 4 over 5. Okay, any questions on that? Yes?
So you're given x and y with the coordinates, but
Yes.
You always find r with everything here?
Yes. And for things like tangent and cotangent, you actually don't even need it.
Okay.
Yep. Any other questions on what I demonstrated?
Why don't you use the
Tangent and cotangent only use x and y. They don't use r, which is the hypotenuse. Okay. Now, let's ask somebody at random. Alec. Jake. You want to try number 30? Yep. Yeah, so what's your first step? Yeah, 18 comma 24. It doesn't have to be perfect. And it's actually not even necessary. It's just, it might help you understand the situation. Exactly.
Draw a line down.
Yep. And how long is this side?
That side would be 24.
24. And this side?
That would be 18.
18. And then since we are finding cosine, we need to find the hypotenuse. So how could you find that?
18 squared. Plus 24 squared
Yep.
equals that squared.
Yep. Good. Go ahead, use your calculator. Good. Good. Add those two numbers. I'm going to go with 900. Good. So we're almost done. Tell me about cosine. What is its definition? Excellent. Very good. Mm-hmm. Mm-hmm. Very good. Okay. So notice here we're just finding r, Pythagorean theorem, and then you just plug it into the definition. There you go. Trig functions, they are nothing to be intimidated by. They're just names. Okay, you just need to know what their definition is. That's all.